Problem number 32. A car starts from rest and moves around a circular track of radius 32 meter. Its speed increases at a constant rate of 0.6 meter per second square. That means the tangential acceleration here is given as 0.6 meter per second square. Now we have to answer for two questions. The first question is, what is the magnitude of its net linear acceleration 15 seconds later? And the second question is, what angle does this net acceleration vector makes with the car's velocity at this time? So here, the first part we have to find the net linear acceleration. That means for finding the answer for net linear acceleration, we need two acceleration value. First one is tangential acceleration and the second one is radial acceleration or centripetal acceleration. So in the question already they gave the value of the tangential acceleration as 0.6 meter per second square. And then also they gave the time period is 15 seconds. Clear? So first what we have to do, let's write the given first and then we can answer one by one. So what is given in the question? The radius of the circular track is given. So radius R, which is equal to 32 meter. And then its speed increases at a constant rate of 0.6 meter per second square. That means the tangential acceleration they gave. So tangential acceleration, which is A of t, here they gave as 0.6 meter per second square. Now what we need the answer for net linear acceleration. So for net linear acceleration, for the net linear acceleration, what we need both value. What are they? We need the value for tangential acceleration and also we need the centripetal acceleration or radial acceleration, because centripetal acceleration, radial acceleration, both are same. So now what we have to do, we already have the value of tangential acceleration. Let's find the value for centripetal acceleration. And for that, what we have to do, we have to write the formula for centripetal acceleration. What is the formula for centripetal acceleration? The formula for centripetal acceleration is v square over r. That means if you want to find the answer for centripetal or radial acceleration, we need the speed. But the speed is not given here. So for finding the answer for centripetal acceleration, first we have to find the value for speed. So what's the formula for linear speed? The formula for the linear speed, in theory we studied v, which is nothing but acceleration multiplied by time, right? Because we studied the formula acceleration, which is nothing but speed divided by time. So therefore speed, which is nothing but acceleration multiplied by time, but here the acceleration is nothing but the tangential acceleration, I mean. Clear? So the tangential acceleration, which is nothing but v over t. So we have to rearrange this equation in terms of v. Therefore we will get at multiplied by t. What is at? Our at value is 0.6 and also the time they already gave in the question as 15 seconds. So what I have to do, I have to substitute the value of time as well as the tangential acceleration here. So 0.6 multiplied by 15 seconds. Here I got the answer for the linear speed as 9 meter per second. What's the answer? 9 meter per second. Now what I am going to do, I have to use this value of v in centripetal acceleration. So let's find the answer for centripetal acceleration. So the formula for centripetal acceleration is given by the rule v square over r. So here v square is nothing but 9 square divided by the radius of the circular track is given in the question as 32 meter. When I divide this 9 square by 32, here I got the centripetal acceleration value as 2.53. The unit is meter per second square. So this is the value for centripetal acceleration. Now you can see we have both the value. In the question, the tangential acceleration is given as 0.6 meter per second square. And then we now got the answer for centripetal acceleration as 2.53. Now it's very easy for finding the net linear acceleration. So the formula for net linear acceleration, which is equal to square root of the tangential acceleration square plus centripetal acceleration square. So what's the value for tangential acceleration, which is 0.6. So I have to square this number, plus centripetal acceleration just now we got as 2.53. So I have to write 2.53 square, and here I got the answer for this as 2.60 meter per second square. This is our net linear acceleration. So this is the answer for the first question. But now we have one more question. Let's read that. What angle does this net acceleration vector makes with the cos velocity at this time? It's very easy. In chapter number 3, we studied vector, right? In that chapter, we studied the rule for finding the angle. What is the formula for the linear for finding the angle? Angle theta, which is equal to tan inverse of here y component over x component. So here y component is nothing but the centripetal acceleration. So centripetal acceleration divided by a tangential acceleration value. So both values we already have in our hand. So centripetal acceleration just now we found as centripetal acceleration. So I can go back. So centripetal acceleration is 2.53. 2.53 divided by tangential acceleration, which is already given in the question as 0.6. I got the answer here as 76.66 degree. If you want, you can just round it to 77. So the angle theta, which is exactly 77 degree. So this is the answer for part B. That's it. Thank you.